Hey kiddos, today we're going to be talking about parallel and perpendicular lines and how to tell if two lines are parallel or perpendicular by looking at their slope. Okay, so first thing we want to do is we want to go in and we want to talk about the definition of parallel lines. So two lines are parallel if they never cross. So remember, parallel is always in reference to two lines, comparing them together. So these lines here, they never cross one another, so those are parallel. Now to tell if two lines are parallel by looking at their slope, what we have to do is we have to identify that the slopes are exactly the same. Okay, so two lines are parallel if they have the same exact slope. Now you'll notice the y-intercept obviously doesn't matter. They can have different y-intercepts. They just have to have the same slope. So for example, in this picture, both of these lines have a slope of 3 or 3 over 1. And so because they have the same slope, they will never cross one another. And that makes them parallel. Now, in relation to kind of what we were doing last week, where we were changing things from standard form into y equals mx plus b, what we're going to do today is we're going to verify and determine if two lines are parallel by converting one into y equals mx plus b and comparing it to the slope of another. So, first example, I want to determine if the given lines are parallel. So what I'm going to do here is I'm going to start with the line that I already can determine the slope of. So on the right-hand side, we already have y equals mx plus b. We have our slope pretty clearly given to us right here. And so that's a slope of negative 1/3. And because we want to tell if the lines are parallel, this is the slope that we're looking for. Okay, we're looking for the same exact slope out of the line here on the left-hand side. Okay, because again, parallel means same slope. So to determine the slope, what I'm going to do is convert this into y equals mx plus b using the same process that we used last week. So I'm going to be subtracting 2x from both sides first. So the 2x and the negative 2x cancel out on the left, the 6y comes down. On the right-hand side, negative 2x and 12 are not friends. They cannot combine together. One has an x and one doesn't, so they're not like terms. So I'm going to write my negative 2x first, and then I'm going to write my positive 12 after that. Now, to get rid of the 6 in front of the y, I'm going to divide. If I divide one thing by 6, I have to divide every other term by 6. So then I have y equals, now I want to reduce this fraction, negative 2 over 6. You can reduce that, simplify by 2. So that's negative 1 over 3x plus 12 divided by 6 is 2. And now you can very clearly see that the slope of this line is negative 1/3, which is exactly the same as the other line. And so the answer is yes, these lines are parallel. Okay. So again, they're parallel because they have the same exact slope. Okay, let's try another one like that. So determine if the given lines are parallel. So again, on the right-hand side, I have a line that's already in slope-intercept form. So I can very easily tell what the slope is, 3 over 4. And because I'm trying to figure out if the lines are parallel, this is the slope that I'm looking for. I have to convert the line on the left-hand side into slope-intercept, y equals mx plus b. So what I'm going to do is I'm going to subtract 6x from both sides. On the left-hand side, these cancel out and 8y comes down. Then I have negative 6x minus 24. Again, they don't combine together because they're not like terms. One has an x and one does not. Now to get rid of the 8 in front of the y, I'm going to divide. If I divide one thing by 8, I have to divide every other term by 8 as well. These cancel out, so y equals, and then I have to simplify this fraction. 6 and 8 can be simplified by a factor of 2, and that gives me negative 3 over 4x minus 24 divided by 8 is 3. Now, looking at this, you have to be really careful. They look similar, but you'll notice that one is negative and the other is not. So they're not the same. They have to be exactly the same to be parallel. So because one is negative, the answer is no. These are not parallel lines. Okay, they do not have the same exact slope. Now, perpendicular is a little bit more complicated. Let's look at the definition of perpendicular lines. Two lines are perpendicular when they cross and make a right angle. So as you know, right angles are 90 degrees. When two lines cross at a right angle, those are perpendicular. To determine if lines are perpendicular by looking at the slope, we use what's called the negative reciprocal. So let's talk about what that means, break it down. Two lines that have slopes which are opposite signs and reciprocal means that the two lines are perpendicular. So if you look at the two in this example, I have one line where the slope is 2/3. I'm going to flip that over. That's my reciprocal. That becomes 3 over 2, and then change the sign. Because one is positive, the other one has to be negative. Okay, so that's how you determine if lines are perpendicular. Now, I want to practice that a little bit. It's not as easy as parallel where you're looking for the same exact slope. So what we're going to do is we're going to look at these 4 lines that are given to us. We're going to write down the original slope, and then we're going to write down what the perpendicular slope would be. Okay, so for my first line, the original slope is 2 over 5. And now the perpendicular slope, I flip that over and change the sign, negative reciprocal. So that would be 5 over 2, and I make it negative. Okay. Second line, y equals negative 3 over 7x, so the slope is negative 3 over 7. That's the original slope. Again, for the reciprocal, I'm flipping it over, and then perpendicular means we change the sign. So that becomes positive 7 over 3. Next line, y equals 2x plus 5. So the slope here is 2, or 2 over 1. For the perpendicular, I flip it over. For the reciprocal, it becomes 1/2. And I change the sign, so it becomes negative 1/2. Last line, y equals negative 3x minus 10. So the slope of the original is negative 3 over 1. Negative 3 over 1. So for the perpendicular, I'm going to flip that over. It becomes 1 over 3. And then I change the sign so it goes from being negative to being positive. Okay, now all of that is really good training for us to recognize perpendicular slope, because what we're going to do next is we're going to compare two equations and see if we can determine if the lines are parallel. Oh, sorry, perpendicular. Okay. So, just like in our first couple examples, determine if the given lines are perpendicular. So, I do have one line that is already in point slope formula, or slope intercept formula. So, right here, 2 over 3x. But unlike the parallel examples, I don't want 2 over 3. Okay, so this is my original slope. So the original slope is 2 over 3. But what I'm looking for is the perpendicular slope. And that is going to be, again, the negative reciprocal. So flip it over, 3 over 2, and change the sign. This is what I'm looking for, because I want to determine if the lines are perpendicular. Now I do the same steps over here. I'm going to move x to the other side by subtracting. 3y comes down. On the right-hand side, I have negative 2x plus 9. I'm going to divide every single term by 3. And so y equals negative 2/3 x, and 9 divided by 3 is 3. Now, if we compare this slope to the one on the right-hand side. This is negative 2 over 3. That is not what we're looking for. It does not match this. Okay? They do not match, so the answer is no. These lines are not perpendicular. Okay? Let's look at our last example. So our last example, determine if the given lines are perpendicular. We're going to do the same thing. We're going to start out with the line on the right side, that's 40 in slope-intercept. This is going to give us a slope of 4/3, but again, that's our original slope, 4 over 3. I don't want that. I'm looking for the perpendicular slope. So what I'm going to do is I'm going to flip it over. It becomes 3 over 4. And then I change the sign, so now it's negative. This is what I'm looking for. That's the slope I want if the lines are actually perpendicular. Okay, so I'm going to subtract 3x from both sides. These cancel out. 4y comes down. Negative 3x plus 20. Now I divide every term by 4. Okay. These go bye-bye, and y equals negative 3 over 4x comes down, and 20 divided by 4 is 5. Now let's compare. The slope of this line, negative 3 over 4, matches up exactly with what we wanted. So the answer is yes, these two lines are perpendicular. Okay. So 2 definitions that you have to know for this lesson. Parallel means same slope. Perpendicular is negative reciprocal for the slope. As long as you remember those 2 things, then you'll be able to do problems like this, no issue.